Today we are going to see how can we generate a mesh over a cleaned geometry model which we already did. So I just not these surfaces to have only my aircraft. Either I can not and filter for the required uh, like like this, or otherwise I can just go to this PID, and then I know that the wind tunnels are named like inlet, side, top, bottom, outlet and symmetry. So just hide all this and you can filter the same. So after this I am just going to lock my selection, and first thing we need to see is we need to go to mesh module, and then we need to understand the concept of length now. Okay, so it is going the length function is in perimeters. Okay, when you access the length function, it will ask whether you want select the perimeters or macros. So I want select perimeters, this one perimeter, and I am setting length of 2000. Okay, if you see, after I put that 2000, you can switch on this perimeter points to better visible. So when I increase the length, the number of points in between the perimeter is reduced. So now again I am going to the same perimeter and changing the length alone to say 20, not 20, 200. See, now it looks almost it captures the geometry well. And you can also make use of this one, um, length maybe 500, and distortion if it is 0.1. See, we have increased the length, but since I applied the value of distortion, what it means is when we um, go along with this perimeter, and the deviation from the geometry is not allowed to go beyond 10 percentage. That is why it has given like this. Simply if you mesh this one surface, you can understand. So going to the mesh generation tab and then selecting the spot mesh, and just select the surface to be meshed, and you can see that you can see this. Okay, now I will change the value. So perimeter length, so since the surface is initially a meshed one which I am going to touch, so I need to, while applying the length, I want to automatically remesh. So I am making it to tick and selecting my perimeter, and I am putting the same length, but now with a distortion value of 0.3. See how it changes. So it was earlier it was capturing these regions very fine. Now it has given the some relaxation. That means from the curve how much my mesh, um, when we actually it is a curve, but when we see it as a mesh, it will be, the elements will be straight. So that caudal deviation is what this one, distortion. For the curves which are um, like this, the distortion is nothing but how well it captures the curvatures. So you can see from the and since I meshed just for demonstration, I am deleting this. Okay, so this is the use of length. So you can apply length to a perimeter to a macro. I am just going to select macros as of now, and I am selecting this macro. And if I set since we earlier set this length as 500, so macro is by default now it sorry, not by default, since we changed it is having 255 to 500. So I am just setting all those things as a common value and 255. So now everything is in a same size. So depending upon your requirement, you can either choose a perimeter or macros. Okay. Next thing we need to see is mesh generation tab. Commonly we use spot mesh as well as map in order to capture the curvatures. So you can understand this map, just map and select some surface, uh, some filleted surfaces, so that you can easily understand. See, if we do map mesh, it captures the fillets accurately. So for the filleted regions, we will be doing our meshing by utilizing map mesh, but we may use the elements here. The element is quad mixed with uh, trias is not there, so I want to make a tria, but I want a map mesh. So since the surface is having mesh, we need to select regenerate, and then since element type is changed here as now, and split trias for equal areas. Okay, now I am selecting the meshed surface to regenerate the mesh. See, after changing our element to tria, it is looking so good. Only thing is, at the end here the flow is not so good, and that we will treat later. First we will understand the meshing algorithm. So you understood the map also. Now we can move forward to generate mesh. So today what we are going to see is a simple mesh. In the near future we will see how to generate mesh which captures each and everything with less mesh count. So that is what the main uh, necessary, because if we increase the number of elements in our model, surely it is going to take much time while solving. So the lead time of the product is increasing. So now I am going to uh, make simple mesh by spot mesh algorithm. Spot mesh element type is tria, and I am just going to select. Before that I will check my length of my aircraft to be 255, and then uh, first I will do for 400, and distortion I am allowing it to 0.2. Okay, it will take some time. Yes, mesh is applied, sorry, length is applied. We need to apply mesh. Spot mesh visible. See, we have two unchecked faces, that's why we have two unmeshed. First we will check out what is uh, the two unchecked faces. We will show those alone. If you see, it is one face of the winglet and one is engine. If you make it as all, you can understand. So this is the unchecked face. We will try to automatically fix it, but it's not fixed. So we need to manually fix it. Go to the geometry. Okay, here if you see, this just has a hanging perimeter, so just I am connecting that with that using the cut function, and I will join that, and since there is a unwanted hard point, I am deleting it. Okay, it treated one thing. Likewise here also, from here to here, from sorry, from here to there. Okay, this is one way of doing. So just I simply erase the mesh. Now just going to the part mesh, sorry, length and macros 255, and my distortion, I am not setting any distortion. Okay, we need to apply mesh on the visible. Before that, let me delete unwanted hard points. Okay, see here and all, the perimeter is not joined, so in this way our model should not be there. There should not be any perimeter which is hanging, because it will affect the mesh flow. Okay, likewise you make it as, I think deviation is applied, because to capture this feature it needs less number of splits. That means the caudal deviation, when we consider for this perimeter, it is large, whereas here it recommends to have a hard point nearby each other. So whenever we apply distortion value, it tries to capture the curvatures accurately depending upon the distortion value which we specify. Now we need to spot mesh visible. See, a mesh has been generated, but this is not accepted, because here the mesh is fine, here the mesh is very coarse, and also it violates the geometry. See, if you make this wireframe off and bounce on, you can see the difference from our model, and perimeters, make the perimeters off. See, this is how it has captured our geometry. Here and all, so many ups and downs. So uh, if this kind of flaws are in our model, means it will not give the correct physics which is running over there, because uh, the solver just knows only the mesh coordinates. So if we specify the element like this, then here and all the flow will be striking, and it will make the different condition than the real one. Here also, especially for external aerodynamics analysis, curvatures are so important. um, why? Because curvatures uh, can accelerate or decelerate depending upon the position and the orientation with respect to the flow. So when the velocity is increasing, the pressure drops. So and this so likewise, the physics is going around this aircraft. So that physics, to if you want to capture exactly, then the curvatures needs to be uh, meshed using the map algorithm, uh, or otherwise our main intention is to capture the geometry accurately. Our mesh model should not deviate much from the geometry. For your demo, I will show you one thing. Make the wireframes on. um, Maybe we may have meshed. I want to just release these elements. Now the elements are attached to this surface, but what I want is, I want to release my elements. So going to elements and release. Yes, elements are released from the surface, and this is the button to toggle off this geometry or on. So I just hidden this. Actually what we have is just a mesh. Okay, so this is not at all connected to the surface. So in this way also, uh, this is the only portion which solver understands. No geometry will not be given to the solver. Only our mesh is going to be the reference for the object which is immersed in the flow.